Hello students, with me Miss Jessica. So since today is our first meeting, so before we begin our lesson, I hope that everyone already read the learning contract that already prepared on Edmodo. So if you did and without further ado, let's begin our lesson. Okay, so today we are going to learn about enzymes. And my first question before we begin our lessons, why you should study about enzymes? Why enzymes is so important and why we care about enzymes? So to find the answer, let's take a look at these pictures. So what can you look? Okay, look at all those mess. So that's actually all the reactions that occurs in our body. But in fact, there's thousands of reactions that occurs in our body, and without enzymes, no reactions in our body. So that's why you should care about enzymes. So what is enzymes? Enzymes is a protein molecule that acts as a biological catalyst. And then what is catalyst? Catalyst is a chemical molecule that speeds up the chemical reactions, but they remain unchanged at the end of the reactions. And usually, the enzymes has a specific name, like they have A's at the end of their name. For example, like amylase, lipase, what else? ATPase, and many more. So next, we're going to discuss about the type of the enzymes. Okay, so since not all the enzymes operate within the cells, so that's why they are divided into two, which are intracellular enzymes and extracellular enzymes. And what are the differences between these two enzymes? So the enzymes that work inside the cells, just like it names, what is that? Intracellular enzymes. Yes, so intracellular enzyme is the enzymes that work catalyze the reactions inside the cells. And then for the extracellular, I guess that you know the meaning of that? Yes, it means that this type of enzymes, it was secreted by the cells, and then they are catalyzed the reactions outside of the cells. So that's why we call it as the extracellular enzymes. And one of the example, okay, not one, few examples of the extracellular enzymes are amylase, lipase, what else? Amylase, lipase, cellulase, and many more. So how enzymes work? So enzymes is a globular proteins, and these enzymes, they have a special sites or features that we call it as active sites. This active site is the place where the substrate to bind with the enzymes. Okay, now let's explain the process of how the enzymes work. Okay, so the substrate or it's the material that we want to process to produce the product. We call it a substrate. So the substrate will bind to the active site of the enzymes. And after that, they will form the enzyme substrate complex. Okay, the interactions between this enzyme and the substrate will break the substrate apart, and they will produce the product. So it means that they will later to form the enzymes product complex. Okay, and after some time, this product will be released from the enzymes, and this is what we call as the product. Okay, now we have the product, and how about the enzymes? So the enzymes, they remain unchanged and they are ready to bind with another substrate. So that is how the enzymes work. There are two theories that explain about how enzymes work. The first one is lock and key. The second one is the inductive. Now let's discuss about the first theory. So the first theory, we call it as the lock and key. So it means that we can imagine based on this theory, enzymes and the substrate, they are complement with each other, like its name, lock and key. So it means that we can imagine that the enzymes has the lock, which has a specific and rigid structures, while the substrate is a key that is supposed to be fit with the active site or the lock. Okay, right? But later on, this theory was modified in light of the evidence that the active sites of the enzyme is not that rigid. Actually, they are more flexible. So this is what we call as the modern hypothesis of the how enzymes work, which we call as induced fit. So basically, it's almost the same with the lock and key theories, but it adds some idea that the shape of the enzymes or the active site and the substrate, they can change a little bit, slightly during the process to ensure fitly with each other. So that is how the enzymes can work more efficiently as the catalyst. Well, in enzymes, they may work by splitting the big molecule or some big substrate into smaller products. Okay, so now let's take a look at these pictures, and you can see this picture on your textbook. Based on this picture, you can see that enzymes, they can work by splitting this big molecule or substrate into two smaller molecules or products. And one of the examples of this process is lipase. Lipase splits the lipids into fatty acids and glycerols, which are more smaller molecules than the lipid. And alternatively, enzymes can also catalyze the reactions of two molecules joining together, as you can see at these pictures. So in these pictures, you can take a look at your textbooks too. So in these pictures, the two smaller molecules or substrate, they are catalyzed with the help of enzymes to form one bigger molecule as a product. Okay, so one of the examples of these enzymes is DNA polymerase. So DNA polymerase synthesize the DNA using the DNA building blocks that we call it as the deoxyribonucleotides. So as catalyst, enzyme increases the rate of reactions. Okay, enzyme increases the rate of reactions, and most of the reactions in living things or in humans, it will not occur or maybe occur slowly if it's not given an enzymes. And in most chemical reactions, the substrate will not be converted into the product unless it was given an extra energy that we call as activation energy. So activation energy used to push the reactions, okay, and extra energy. So catalysts or enzymes as a catalyst, they work to increase the rate of reactions by lowering the activation energy. So it means that the reactions that should be occur in higher temperature or with the need with more energy can occur in lower temperatures or lower energy. Okay, let's take a look to make it more clearly. Let's take a look at the graph here. Okay, this graph you can take a look at your textbook too. So okay, in this graph you can see that the reactions with the enzymes will occur at lower energy with the need with lower energy compared the reactions that occurs without an enzyme. So in short, we can conclude that these enzymes as a catalyst, it works to increase the rate of reactions by lowering the activation situations energy. So if you want to know more about these reactions, you can read your books on page 57. So that's all for our topic today. So how was it? Is it difficult? I think not, right? So after watching this video, I hope please do the exercise and don't forget to submit it on Edmodo. And see you next time. Bye.